Most students struggle with circuit analysis. But what if I tell you, you can solve any circuit using just node voltages? Welcome back to the channel, everyone. Today we are diving deep into one of the most powerful tools in electrical engineering, called nodal analysis. Think of it as the master key that unlocks even the most confusing circuits you will ever come across. Let's start with the big question. What exactly is nodal analysis? In very simple words, it is a method where we find the voltage at specific points in a circuit, called nodes. The whole thing is based on a very famous law called Kirchhoff's current law. Now, imagine we have a circuit in front of us. On one side, we have a 4 milliamp current source pushing energy in. In the middle and on the sides, we have 3 different resistors, and at the far end, there is another 2 milliamp current source. Our goal here is to find the voltage at 2 specific spots. Let's call them node 1 and node 2. To make this work, we first look at the very bottom of the circuit and call it our ground or 0 volt point. Everything we measure will be relative to this bottom line. Let's focus our attention on node 1 first. If you look at this spot, there are 3 paths for the current. One path goes down through a 6 kilo-ohm resistor to the ground. Another path goes sideways through a 12 kilo-ohm resistor toward node 2. And then we have that 4 milliamp current coming directly into the node. To write our conversation for this node, we say the voltage at node 1 divided by 6,000 plus the difference between node 1 and node 2 divided by 12,000 minus the 4 milliamps coming in, all equals 0. To make this easier to handle, we multiply the whole thing by 12,000 to get rid of those big fractions. After a bit of basic cleaning up, we get a very clean relationship. 3 times the first voltage minus the second voltage equals 48. That is our first big piece of the puzzle. Now, let's shift our gaze over to node 2. This spot is also connected to 3 things. It has a path going down through its own 6 kilo-ohm resistor to the ground, a path going back toward node 1 through that same 12 kilo-ohm resistor, and a 2 milliamp current source that is actually pulling current away from the node. For this spot, we say the voltage at node 2 divided by 6,000 plus the difference between node 2 and node 1 divided by 12,000 plus the 2 milliamps leaving the node, all adds up to 0. When we clean this one up by multiplying by 12,000 again, we get our second piece of the puzzle. 3 times the second voltage minus the first voltage equals negative 24. At this point, you have 2 simple equations and 2 unknown voltages. This is where the magic happens. By just using basic substitution or elimination, you can find the exact voltage at both points. Once you have those voltages, you can find the current through any resistor or the power used by any part of the circuit. Before we wrap up, I want to mention a few traps students often fall into. The biggest mistake is forgetting to pick a ground. Without a 0 point, your numbers have no meaning. Another common slip-up is getting the signs wrong for the current sources. Remember, if it's coming in, it's usually treated as a negative in the sum, and if it's leaving, it's positive. Nodal analysis might look intimidating with all the resistors and wires, but if you just take it node by node and keep your directions consistent, you can solve literally any linear circuit. I hope this breakdown makes you feel more confident about your next exam or project. If you found this helpful, hit that like button. Share it with your classmates who are also scratching their heads over circuits. And don't forget to subscribe for more engineering deep dives. Thanks for watching, and I'll see you in the next one.